We present CoolDrip, a Ghost SPH water simulation plugin for Maya, a project by Dongqing and Yoonho Chang. The goal and objective of the project was to build a Maya plugin that can simulate the realistic behavior of Ghost SPH fluids. It is intended for use among both artists and technical directors. We hope to deliver a plugin capable of simulating realistic fluid behavior with easy control of fluid parameters. The fluid simulation approach we follow is outlined in the paper Ghost SPH for Animating Water, which was presented at CGRAPH 2012 by Haggett Schechter and Robert Britson from the University of British Columbia. The methods presented in the paper apply ghost particles for SPH simulation to get better control of water and more realistic behavior of fluid-solid interaction. The SPH method they utilize stems from the 2005 paper Smoothed Particle Hydrodynamics by Monaghan. We also utilize the fast Poisson disk algorithm, which would help the construction of our particle system, help to handle arbitrary dimensions and more casual geometry in a faster way. This method can be found in the paper Fast Poisson Disk Sampling in Arbitrary Dimensions by Britson. Here is a brief overview of how our tool works. First, in Maya, we assign the fluid attributes and get geometry data. Then, all the information is passed to our C++ Ghost SPH simulation program, where we generate ghost particles through a fast Poisson disk algorithm and calculate the fluid particle physics. Then, the location information of all the particles are then sent back to Maya for rendering.
This is the procedure for Maya users. We click on CoolDrip and try to create the Ghost SPH. Here we can modify some of the attributes, such as the boundary, the fluid, and the solid geometry. We can also modify the gravity and the frames we want to simulate. If we set the solid radius to 0, the solid geometry will not be created. And if we click on the Create button, the simulation will be going on. The output will be the text files with all the position data of the fluid particles, and it takes around 2 seconds per frame to compute. After computation, we can click on Read Results to read the files and create n-particle nodes. The nodes is time dependent, so that we can click on different frames to check the status. And the n-particles can be modified as mesh and rendered as fluids after this. This is the result of our sampling algorithm. The red particles are solid particles within 1 canal radius inside the solid, and the dark ones are liquids. The blue ones are air particles surround the fluids. The liquid and solid particles are generated at the very beginning of the simulation, and the generation procedure is relatively time-consuming. This video shows the dynamic generation of air particles around the liquids. The simulation of SPH is around 2 frames per second, and after every 10 time steps, the air particles will be regenerated to keep the free surface condition. The density of air are set to the rest density of liquid, so that it produces zero pressure. The generation and relaxation of time for air particles depends on the status of the liquids. This video shows the interaction of fluids and solid geometry. With current parameters setting, the particles are prevented from penetration into the solid geometry. However, the viscosity and the surface tension parameters are not perfect yet. And these are the future work we're interested in. Thanks for watching.